Have you ever looked up at the night sky and wondered if our universe is all there is? What if I told you that everything we know, every star, every galaxy, every planet, might just be a single sheet of paper floating in a much larger, unseen reality? This isn't science fiction. It's a mind-bending concept from the frontiers of theoretical physics called Brane World theory. Let's dive in. To understand Brane worlds, we first need to touch on their parent idea, string theory. For decades, physicists have been on a quest for a theory of everything, a single framework that unites the two pillars of modern physics: general relativity, which describes the universe on a grand scale, think planets and galaxies, and quantum mechanics, which governs the tiny world of atoms and particles. String theory is one of the most promising candidates. It proposes that the fundamental building blocks of reality aren't point-like particles, but unimaginably small, vibrating one-dimensional strings. Just like a violin string can produce different notes depending on how it vibrates, these cosmic strings vibrate in different ways to give rise to all the different particles we see, like electrons and photons. Here's where it gets truly wild. For the math of string theory to work, it requires more dimensions than the 3 of space and 1 of time that we experience. Most versions of the theory predict a universe with 10 or 11 dimensions. So where are these extra dimensions? The theory suggests they are compactified, or curled up so tightly that they're completely invisible to us, like a single thread in a thick rope that you can only see up close. Imagine an ant walking on a garden hose. From far away, the hose looks like a one-dimensional line, but for the ant, it has a second dimension it can walk around. Our universe could be similar, with hidden dimensions all around us that are just too small for us to perceive. This is where the brane part comes in. The word brane is short for membrane. In this theory, our entire 4-dimensional universe, 3 space, 1 time, is a massive membrane or brane floating within a higher dimensional space, often called the bulk. Think of our universe as a giant, flat sheet of paper. This sheet contains all the matter and energy we know. We and everything we can interact with are stuck to this brane. We can move forward, backward, left, right, up and down and through time, all within the confines of our own sheet of paper. But we can't easily jump off it into the higher dimensional bulk that surrounds us. This explains why we don't see those extra dimensions. The particles and forces that make up our world, like light, are open strings with their ends attached to our brain, so they can't leave. They're like beads on a wire, free to slide along the wire, but not to fly off into the surrounding space. This is why we can't just see into the 5th dimension. However, there's one force that might be an exception: gravity. String theory suggests that gravity is different. It's represented by closed strings, tiny loops that aren't tied down to any specific brane. This means gravity is free to leak out of our brain and travel through the bulk into other dimensions. This could be the solution to a long-standing mystery in physics. Why is gravity so incredibly weak compared to other forces like electromagnetism? You can prove this yourself. A tiny refrigerator magnet can overcome the gravitational pull of the entire Earth to pick up a paperclip. The Brane World theory suggests that gravity only seems weak to us because a lot of its strength is seeping away into these extra dimensions. We only experience a small fraction of its true power. Now let's take this idea one step further. If our universe is one brane, could there be other branes out there? The theory says yes. Imagine not just one sheet of paper, but a whole stack of them, all floating parallel to each other in the higher dimensional bulk. Each of these branes could be its own universe, with its own set of physical laws, its own particles, maybe even its own form of life. These are the parallel universes of brane cosmology. They could be just a millimeter away from us, in a higher dimension, yet completely inaccessible and invisible. We are separated by a dimensional gulf that for the most part we cannot cross. But what happens if they're not perfectly still? What if these cosmic membranes can move, ripple, and even collide? This leads to one of the most spectacular ideas in all of cosmology: the Big Bang as a brane collision. Some physicists propose that the event that created our universe wasn't a singularity from nothing, but a cataclysmic impact between two parent branes. Imagine two of these giant universal sheets drifting through the bulk and eventually crashing into each other. The unimaginable energy released from this collision would be so immense that it could heat the brane to an incredible temperature and density, triggering a massive expansion, a Big Bang, and creating all the matter and energy that would eventually cool and form into the galaxies, stars, and planets of our universe. This model, known as the ekpyrotic or cyclic universe model, suggests that the Big Bang wasn't a one-time beginning. Instead, these brane collisions could happen over and over again. The universes expand after a collision, cool down, and then, pulled together perhaps by a spring-like force in the extra dimension, they eventually collide again, resetting the cycle and starting a new cosmic era. In this picture, our universe could be just one in an endless series of creations and destructions, a phoenix constantly reborn from the ashes of a previous cosmic fire. So, how could we ever test such a bizarre idea? It's incredibly difficult, but not impossible. If gravity can leak between branes, we might be able to detect its influence. For example, high-energy particle collisions at places like the Large Hadron Collider could potentially create tiny, short-lived black holes or produce particles that vanish from our detectors as they escape into another dimension. We haven't seen this yet, but the search is on. Another potential clue could be found in the cosmic microwave background radiation, the faint afterglow of the Big Bang. Specific patterns or anomalies in this radiation might hold the signature of a pre-Big Bang era, or the influence of a nearby brane. While Brane World theory remains on the cutting edge of speculation, it's a powerful and elegant idea. It reframes our place in the cosmos, suggesting that our universe is not an isolated island, but part of a much larger, more dynamic, and infinitely more mysterious multiverse. It challenges us to think beyond the familiar, to imagine a reality of hidden dimensions and cosmic collisions. The universe might not just be stranger than we imagine, it might be stranger than we can imagine. Thank you so much for joining me on this journey into the weird and wonderful world of branes. If you enjoyed this cosmic exploration, please give this video a thumbs up, and don't forget to subscribe and hit that notification bell so you don't miss our next adventure into the mysteries of science. See you next time. Have you ever looked up at the night sky and felt a sense of overwhelming smallness? We see billions of stars nestled within our own Milky Way galaxy, which is just one of hundreds of billions of galaxies in the observable universe. But what if I told you that all of that, every star, every galaxy, every single thing you've ever known, might just be a tiny speck within something infinitely larger? What if our entire universe is just one bubble in a vast cosmic ocean of other universes? This isn't science fiction. It's a mind-bending concept from theoretical physics called the multiverse, specifically the bubble universe or eternal inflation model. It's one of the most profound and exciting ideas ever conceived. So, buckle up, because today we're going on a journey beyond the edge of our own reality. To understand bubble universes, we first need to talk about the Big Bang. We know that about 13.8 billion years ago, our universe began from an incredibly hot, dense point and has been expanding ever since. But what caused the Big Bang? A leading theory is called cosmic inflation. Imagine in the first fraction of a second after the Big Bang, the universe expanded faster than the speed of light. It was an explosive, exponential growth, stretching the fabric of space-time itself. This inflationary period smoothed out the universe and set the stage for the formation of galaxies and stars. Now here's where it gets really interesting. According to the theory of eternal inflation, this process of inflation might not have been a one-time event. Instead, think of it as a constantly boiling pot of water. Our universe is like a single bubble of steam that formed and expanded within this eternally boiling, inflating space, which physicists call the metaverse, or the bulk. But in this cosmic pot, new bubbles are constantly forming. Inflation stops in certain patches like ours did, allowing a universe to cool down, form matter, and evolve. But outside our bubble, in the vast expanse of the metaverse, inflation continues forever. And in other regions of that metaverse, inflation will also randomly stop creating other bubbles, other universes. Each of these bubbles would experience its own Big Bang, completely isolated and inaccessible from our own. So picture this, an endless cosmic foam. Our universe is one bubble. Next to it, separated by an ever-expanding void, is another bubble, and another for infinity. An endless sea of bubble universes, each one a complete cosmos in its own right, bubbling up from the eternally inflating metaverse. It's a staggering thought. We're not just on a pale blue dot in one galaxy. Our entire observable universe might be just one bubble in a cosmic bubble bath. What would these other universes be like? This is where the theory takes an even wilder turn. Each time a new bubble universe forms, the fundamental laws of physics could be completely different. Imagine a universe where gravity is 10 times stronger, making stars burn out in an instant and preventing planets from ever forming. Or a universe where the electromagnetic force is weaker, meaning atoms could never hold together. The constants of nature that we take for granted, the speed of light, the charge of an electron, the strength of gravity, might just be random outcomes, like a cosmic roll of the dice for each new bubble. In our universe, these values are perfectly tuned for life to exist. If they were even slightly different, we wouldn't be here. This is sometimes called the fine-tuning problem. Why is our universe so perfect for us? The bubble universe theory offers a simple, elegant answer. It's not that our universe was specially designed for us, it's that we exist in one of the few bubbles where the conditions happen to be right. In the vast majority of other universes, the laws of physics are probably hostile to life. They might be empty, dark, or fleeting, but with an infinite number of bubbles, it's statistically inevitable that some, like ours, would have the winning lottery ticket, the right combination of physical laws for stars, planets, and eventually, life to emerge. We are here because we couldn't be anywhere else. So, could we ever travel to one of these other universes? Unfortunately, the answer is almost certainly no. Remember, the space between the bubbles is the part that's still eternally inflating. It's expanding faster than the speed of light. Trying to cross that gap would be like trying to swim upstream against an infinitely powerful current. No matter how fast you travel, the distance to the next bubble would be growing even faster. They are, for all practical purposes, forever beyond our reach. But could we see any evidence of them? This is where science gets creative. Some physicists have proposed that if another bubble universe collided with ours in the distant past, it might have left a bruise on our cosmos. This cosmic bruise could appear as a strange cold or hot spot in the cosmic microwave background, the leftover radiation from our own Big Bang. Scientists have been searching the data from telescopes like the Planck satellite for such anomalies. So far, the results are inconclusive. They've found some intriguing spots, but nothing that can be definitively called evidence of a collision with another universe. It's a long shot, but the fact that we can even look for such evidence is incredible. We are literally searching for the echoes of another reality in the faint glow of our own universe's birth. Another mind-bending implication of the bubble universe theory has to do with infinity. If there are an infinite number of bubbles and the laws of physics can vary, then anything that is physically possible will happen an infinite number of times. This means that somewhere out there in another bubble, there's a universe almost identical to ours, but where you decided to have a different breakfast this morning. And it gets weirder. In another bubble, there's a version of you who is an astronaut. In another, dinosaurs never went extinct. And in an infinite number of others, there are exact copies of you, living out this exact moment, watching this exact video. Every possible choice, every possible outcome, is being played out across the multiverse. Your life isn't just one story. It's an infinite library of stories. Of course, it's crucial to remember that this is still a theory. Eternal inflation and bubble universes emerge from our best models of the early cosmos, like string theory and inflationary cosmology, but we don't have direct, concrete proof. It remains on the cutting edge of theoretical physics, a beautiful mathematical idea that is incredibly difficult to test, but whether it's ultimately proven true or not, the concept of the bubble multiverse fundamentally changes our place in the cosmos. It suggests that reality is infinitely larger, richer and more mysterious than we could have ever imagined. It takes the Copernican principle, The idea that we are not in a special, privileged place in the universe, to its ultimate conclusion. We are not just on one planet among many, in one solar system among many, in one galaxy among many. We may be in just one universe among an infinity of others. The next time you gaze at the stars, think about this. Beyond the farthest galaxy, beyond the edge of our observable universe, there could be a cosmic foam of countless other realities, an endless expanse of creation where every possibility is realized. It's a humbling, awe-inspiring thought that expands not just our universe but our imagination. What do you think? Is our universe just one bubble in a cosmic foam? Let me know your thoughts in the comments below. And if you enjoyed this journey to the edge of reality, don't forget to hit that like button and subscribe for more deep dives into the mysteries of the cosmos. Thanks for watching, and keep looking up.